Okay, so today we're going to start a brand new topic, and it's called antidifferentiation. So we're going to do this over 2 days. Antidifferentiation is the opposite of differentiation. So you are basically going to be working backwards. So you're going to do the power rule in reverse. You're going to do natural log rule in reverse. You're going to do E rules in reverse. So we know many rules for taking derivatives of functions. Now, as I said, we're going to work backwards and get the original function from the derivative. Okay, we're going to call the derivative f of x. Okay, so let me just go back. Okay, so the derivative is going to be f of x. And the antiderivative, the original function, is capital F of x. Okay, so basically, f of x is actually, if you want to think of it this way, f prime of x. Okay? You have to wrap your head around this a little bit, so give yourself some time to figure all this out. We're going to do something called indefinite integration. Okay, so basically there are no endpoints. We'll get into this later on, but there are no endpoints with indefinite integration. So finding the antiderivative of a constant. Okay, so if your f of x is 3, and that's the derivative, what was it before you took the derivative? So think about this. If 3 is the derivative, couldn't the original function, the capital F of x, be 3x plus 7? Well, let's check. Okay, if you take the derivative with respect to x of 3x plus 7, don't you get 3? Okay, so that checks. What if you take the derivative with respect to x of 3x minus 10? Don't you also get 3? Likewise, if you take the derivative with respect to x of 3x plus 10,000, you also get 3. So that means that there is more than one answer. So how do we take account of these additional answers? Well, the answer is in this C. Okay, this C gets added to every indefinite integration. It takes account of the possibility that you could have had a constant in your answer or in your original function. So that C is called the constant of integration. And you always want to remember to put it in your answer. So we will go over this some more. So the big thing is it allows for all the possible answers, and don't forget the C. Okay, let's go on to the next page. Okay, so as I said before, we have many rules of taking derivatives. Well, there are many rules for taking antiderivatives. So the first one we're going to talk about is finding the antiderivative of a variable raised to the power. So let me go back for 1 second, because really this is our second rule. We've now figured out how to find the antiderivative of a constant just by adding the variable to that constant and adding a C. Okay, so now this is our second category. Finding the antiderivative of a variable raised to a power. Okay, this is your f of x. So that means that this was the derivative of some other function. Well, what was that function? Well, I am going to say, just to state, that that was the function. So let's see if we can get this back. If I take the derivative with respect to x of this f of x, okay, what am I going to get? Well, bring the 2 down, the 2's cancel, and I get x. The derivative of a constant is just 0, so I am done. So, do you see how these are the same? So now we have a rule. If you have a power, so you have a variable raised to a power, then the way to get your original function is to add 1 to the power, whatever number you end up getting, put it in the denominator. Okay, this only is going to work where r does not equal -1. If you add a 1 to your r, you're going to be dividing by 0, which is undefined. So if you ever find that you're dividing by 0, know that you can't do that. There's another rule for that. Let's try one, and then we'll try additional ones. What if I said f of x equaled x to the 7th? I'm going to contend that f of x, the original function, is going to be, I'm going to add 1 to the 7, I get 8, and I divide by that same 8, and I add c. So let's see, if we take this derivative, will I get that original function back? So the derivative with respect to x of f of x, isn't it going to be, the 8 comes down, the 8 over 8 cancels, and you have x to the 7, and the derivative of a constant is just 0, so done. So notice, this equal this, we're all good. So what if I introduce a constant? Does that really change anything? And the answer is no. Look what happens. If I have a constant here, then the constant just goes along for the ride, right here, and you still do the same +1 on the numerator, and then that becomes a divisor. Okay, so let's try one that has a constant in it. What if I said f of x equals 6x to the 3rd? I want to know what the original function is. So I'm looking for f of x. Because remember, this little f of x is really f prime of x. Okay, so let's see. What's my rule? The constant comes along for the ride. Raise the x one more, so that makes it to the 4th, over 4. Don't forget the constant of integration. Okay, so that's going to equal 3/2 x to the 4th plus c. So when we check it, take the derivative with respect to x of f, and we're going to get, the 4 comes down, so I'm going to get 12 over 2 x to the 3rd. The derivative of a constant is 0. That's done. Doesn't that equal 6 times x to the 3rd? And aren't we all set? Okay? So ready to go on another page. Now I'm going to introduce the notation associated with integration. So this is our notation. This is called, the 3 is called our integrand. Okay, I'm not going to write it, well, I'll write it up here. It's called our integrand. Our integrand was the f of x, or if you want to think of it as the capital F prime of x. Okay? I have to always write the dx or dt or whatever it's going to be. This tells me what my variable is going to be. Is it going to be x? Is it going to be t? That's going to determine that. Okay? And this symbol is called my symbol of integration. So our example 1, it says find the original function. So take the antiderivative or integrate 3 dx. So that's a constant. So the answer is going to be 3 times x plus c. And to check it, remember you always have an answer key. To check this, take that derivative, and you do indeed get 3, which is what I wanted. Okay, let's do the next one. Here is our example 2. Your integrand is x. The function is going to be in terms of x. That's what the dx tells me. And the integral symbol is in front. These are called indefinite integrals because there are no numbers over here and over here. Okay, we won't really get to that today, but know that there are no endpoints. Okay, so what are we doing? Let's figure out what they're asking us to do. They're saying that this x was the f of x, or f capital F prime of x. Find the original function, and I contend that with the power rule, I'm going to add 1 to the power 1 that's already there. That gets me 2, and then divide by 2. Now to check my work, take the derivative of this. So the 2 comes down, the 2's cancel, and that leaves us with x. The derivative of a constant is 0, so it just leaves us with x, and that does indeed match this. Okay, so this is not rocket science, but you have to really be thinking about this. Okay, finally, writing our final generalization. What if I throw in a constant? How does that impact things? And it does not. But here is the whole notation of integration for this kind of problem. Let's make up one and see if we can work it out. What if I said I had 2x to the third dx? So this is my integrand. I know my variables are going to be x, and I have my integration symbol right there. Okay, what is that? What is the antiderivative of that? So I'm going to have the 2 come along for the ride, write my x down, add 1 to the 3, that makes it 4, also divide by the 4, and don't forget the constant of integration. Okay, so I'm going to reduce that. That is 1/2 x to the 4 plus c. Okay, make sure that is correct, as I'm trying to make sure I have a good skill set with this. If I want to take that derivative, what do? Bring the 4 down. 4 over 2 is 2. That gives me 2x. Reduce the power by 1. That's 3. And the derivative of a constant is 0. So I'm all set. And this matches my integrand. So I know I'm good to go. Okay, another page. Okay, other rules of integration that you will need to understand and also to memorize. Okay, what if we're dealing with e? Here's your integrand, e to the kx dx. So I'm telling you that the antiderivative is going to be 1 over k, and notice that k was right here, 1 over k, and then e to the kx. So you write what you see, and then previously we would have multiplied by k, but since the antiderivative, you do the opposite, you divide by k. All right, and then let's introduce a variable, another variable of j, and this is that setup. So let's try one. What if I say I want the antiderivative of e, well, we'll do the whole thing, so let me back out. Okay, of 3e to the 2x. And I have to tell you what the function is going to be a variable of, so it's going to be an x. And what's my rule? Write down the 3, that constant comes along, e to the 2x comes along, and instead of multiplying by 2, when I take the derivative, I divide by 2. And then I'm going to have to add the constant of integration. Okay, check your work. Working backwards. This is 3e to the 2x over 2. I'm taking the derivative. I write down what I see, which is 3 over 2 e to the 2x, and I multiply by the derivative of the power, which is 2, and the derivative of a constant is just 0, so that's gone. These cancel, and I do indeed match my integrand. Okay, there's one more I want to talk about, and that's natural log, working with natural logs. Now, do you remember when I said if you have an x in the denominator, if you end up dividing by 0, that's not going to work? Well, I want you to recognize whenever you have x to the negative 1 or 1 over x, the power rule is not going to work. That is going to be instead natural log. Okay, so let's say I had something like this. I had 7 over x dx. That would equal 7 natural log of x plus c. Okay, check it out. Take the derivative. 7 natural log of x plus c. That's going to be 7. And it's going to be, that derivative will be over x, right? 1 over x. And then the derivative of a constant is just c. So this derivative matches my integrand, and I know I understand what's going on. Okay, this last little thing is not really a rule. It's just kind of something that we did in derivatives, and the same thing works for integration. Okay, so the integral of a sum is the same as breaking it up and doing each little piece by itself. Okay, so that just is good to know. We did it with derivatives. We do it also with antiderivatives, which would make perfect sense. Okay, let's go on to the next page. Okay, now we're finally ready to do some more practicing. So see if you can apply those rules. You can stop the video and try to do some of these yourself, and then come back and see how you did. Or you can just follow along with me. It's up to you. Okay, so f of x equals the integration, or the antiderivative of 7 dx. It's a constant, so I know my rule is going to be this. Add the variable, and then don't forget the constant of integration. Okay, here's a power rule. So my f of x is going to equal, add 1, divide by the same thing, add your constant of integration. Okay, here's e. So think about what the e rules are. I'm going to write what I see, and instead of multiplying by 2, I'm going to divide by 2, and I'm going to add the constant of integration. Now with each of these, if I take the derivatives of the capital F of x function, I will get back my integrand. Okay? All right, let's keep going. Okay, look at 4. Now the function is in terms of t. So that's why over here it says dt and not dx. Okay? So but you're going to handle it the same way. So that looks like a variable raised to a power. So I'm going to use the power rule. So f of t is going to equal t. I'm going to add 1. 7 halves plus 2 over 2 is 9 halves. I'm going to divide by 9 halves, but it's a lot neater to multiply by 2/9. And then add your c. Okay, look at the next one. We have just a plain old x. So this is just an easy one. So that's x to the 1. So then make that x to the 2 over 2 plus c. Okay, now this last one is a little bit more complicated. This is a situation where an integral of a sum is going to equal the sum of the integrals. Okay, so I think I'm going to do 6 down here. So let me change colors again, and this will be 6. Okay, so I may want to rewrite 6. So I only need to really rewrite one little piece of it. So this is x cubed over 3 plus, I'm going to bring this up so it's easy for me to think about. And let's bring this up and just see what happens. Okay, so now I'm ready to go. So do each part. Okay, so the first one is going to be add the power, add 1 to the power that's currently there. And so that's going to be x over 4, and then divide by that. Well, since I have a 3 down the bottom already, I'm going to multiply the 4 by the 3 and get a 12. Okay, next one. The constant comes along for the ride. Write down your x. Add 1 to that exponent. That's going to make it -3 plus 1 is -2. And divide by -2. That means that this sign will be a subtraction. Okay, don't double up your signs. Make it a subtraction. Okay, now look at this next one. If I add 1 to -1, I'm going to get a 0. I can't divide by 0. Where have I heard this before? Oh, right. That must have been natural log. And then add your constant of integration. Okay, so that's it for the first day, really. Let me just look on. Yeah, that's it for the first day. And now you're going to do the worksheet, only the first half of it. And that'll just get you going.